So I wanted to say also what a pleasure it is to be invited to speak to this group. Even though I'm a local, I have to tell you that it matters to me very much that I'm able to speak to you here today. I have a great deal of respect for people who work in agriculture everywhere. And as everyone in this room knows, water is absolutely critical to agriculture, and agriculture is critical not just to the economy, but also to human dignity and well-being everywhere. And the relationship between water and agriculture in Canada, in my estimation at least, appears to be changing. And my recent experiences in traveling across this country and abroad suggest that there's a growing sense that there is something unexpectedly happening out there, and that maybe something is going wrong in the larger world that goes way beyond what is happening in terms of our current economic situation. And whatever it is, and we're seeing this widely, it seems to be coming at us fast, and it appears to be connected to water. So to figure out what's really happening and how to respond, we may need to stand back from the furious debate that we're having in this country over global warming and reframe the climate argument in its rightful broader context, as many of you have done. Now, while progress is being made, it remains scientifically difficult to determine exactly how much of current variability we can attribute to anthropogenic climate change effects as differentiated from other human influences on both water and climate. And new research, and Bill was talking about variability here, new research on the cyclic effect of ocean currents such as El Nino and its sister La Nina, as well as recent revelations regarding the telekinetic effects of the Pacific Decadal Oscillation on the precipitation patterns of the continent of North America, suggests that there's a great deal we just don't know about the extent and character of natural variability. And what's also interesting is that I think we needed to be reminded now and then, before anything else, that the situation to which we must adapt is first and foremostly ecological in origin. We have changed our landscapes in many regions of southern Canada, and in some cases quite dramatically. And secondly, the situation to which we must adapt is in part hydrological, in that by changing the character of the land and abstracting more water for our purposes, we have altered both surface flows and groundwater recharge. And at the same time, we're leaving less water for nature to use. And in so doing, we reduce the amount of water nature has for its purposes and how much it can purify for our use. And these are important considerations. And finally, our situation is climatic in that if you alter the land and change its hydrology, the climate invariably changes also. And add more substances that already compose it to the atmosphere, such as carbon dioxide and methane, then eco-hydroclimatic change accelerates even further. Now, all this said, our research and our initiative suggests that we have not yet even begun to feel the influence of global warming per se. That will come. What we're experiencing presently are primarily the combined early effects of rapid, accelerating, and in many cases irreversible eco-hydroclimatic change. And the challenge for agriculture, of course, is to stay ahead of what's happening, especially as it relates to water security. And as you all know, water security is getting to be a real hot issue everywhere. And in this matter, our oceans and our atmosphere are increasingly seen as really important players. And I want to point out that this is entering the public imagination. This is an advertisement for a new ski movie that premiered and toured across North America this past winter. I love it because the implication here, of course, is that La Nina events bring less snowfall to some mountain areas, which in turn cause havoc in ski areas, as you can see. Now, though not entirely correct in its assumptions, this advertisement does signal the beginning of the way that, a change in the way that we're actually thinking. If we accept that patterns of ocean circulation do affect seasonal weather, and that our hydrology in this country is in fact on the move. We're forced to examine broader hydroclimatic processes in the context of how much water is going to be available where we live in the future. And this is where I think things get really interesting, because we know that changes at the ocean-atmosphere interface cause cascading effects elsewhere. And loss of glacial ice and reduction in snowpack and snow cover in the Mountain West are clear evidence that our country's hydrology is, in fact, changing. What scientists have been saying for nearly 10 years is that the hydroclimatic conditions that are emerging are increasingly outside the established range of what Canadians have demonstrated an ability to adapt to over the last century. And this is the new normal that researchers like Dr. David Soshin at the University of Regina and others are telling us that we have to adapt to now and in the coming decades in the central part of this continent. And of course, that adaptation speaks directly to the importance of agriculture and how it responds to these circumstances. So what we see is that it's anticipated that this variability is likely to increase in the future, which will result in extensive and very costly ongoing damage, not just to public infrastructure such as roads and bridges and dams and water treatment plants, but to our entire built, natural, and agricultural environment. And as we don't know how far these changes are going to go, the costs of adapting to these changes are presently incalculable. But the insurance industry is already giving us warning of what these concerns will look like in the future. In August of 2011, the Insurance Bureau of Canada observed that the number and severity of storms in Canada is having a negative effect on the industry, and insurers are particularly worried about the rapidly increasing rate of water-related damage claims. Now we see that instead of it used to be fire and theft that the insurance industry is worried about, half of every dollar now paid out by insurance companies is for water damage. In Minot, North Dakota, for example, some 3,300 homes were flooded last spring and summer. Some under 64 feet of water, which means you're not going to be using these buildings again. And what's interesting about that is that the problem was that only 230 had flood insurance. So what we see from that is that we're beginning to see losses related to these extreme weather events at a very highly personal level. And in last year, as many of you will know, in Manitoba alone, flood relief cost more than $800 million. And losses related to agricultural production on the prairies were likely in the same area in terms of cost. Now, the point I want to make here is that if flooding of this magnitude persists, it could make a province like Manitoba poor. And you can bet that this is not lost on the government of Manitoba and the people who live in that province, and I'm sure it's not lost on any of you. We're not the only ones confronted by such changes, and it looks as if we're going to have a lot more company in the future. Scientific attention focused on atmospheric dynamics related to hydroclimatic changes has revealed some very, very interesting phenomena. Researchers, for example, have discovered the presence of what are called atmospheric rivers, monster conduits of water vapor the size of 100 Mississippis roaming through the sky looking to deposit huge volumes of water, often on the unsuspecting. And what we know is that atmospheric rivers have probably been around for eternity, but now they're overflowing their cloud banks in ways that we've never witnessed before. They are suspected of producing floods of the magnitude that we saw in Australia and Pakistan in 2010. And now we're beginning to sense from research that they may also have played a role in the flooding that we saw in North America and the central part of the continent in 2011. And as all of you clearly appreciate, the effects of widespread flooding on this scale are not contained within provincial or national borders. They can affect food and commodity prices globally in an almost instant way, as we saw recently in Thailand. So to understand what is happening and why it's such a threat to established stability, it's important to understand the central role that water plays in our planet's weather and climate system. And the fundamental threat that eco-hydroclimatic change poses is to what hydrologists call stationarity. Stationarity is the notion that seasonal weather and long-term climate conditions fluctuate predictably within established averages. This perceived stability permits us a relatively high degree of certainty when it comes to predicting and managing the effects of weather and climate on our natural systems, on our cities, and also on our agricultural production. And the fact that we have determined that natural phenomena fluctuate within a fixed envelope of certainty suggests, for example, that, well, winters are only going to be so cold and summers so hot. Stationarity suggests that melt from winter snowpacks will always roughly contribute the same amount of water to our rivers, and that our rivers will only rise so high in spring and fall so low in autumn. Stationarity also suggests that we only have to build, and this is for you working in agriculture, stationarity also suggests that we only have to build culverts to a certain size because we know from history that rainstorms only last so long and only result in so much runoff. Stationarity also suggests that storms will be of predictable intensity and duration and follow established tracks, and that really extreme events like tornadoes will only form in the most extreme conditions of weather that we come to know and expect. So what I'm saying here is that stationarity suggests that the world will be pretty much as we've observed it in our time, and that we'll be able to deal with what nature throws at us. But what is happening now is that changing eco-hydroclimatic circumstances are altering the manner in which water moves through the hydrological cycle. And what we're seeing is the hydrological cycle is being energized. And this means that the statistics from the past related to how surface, subsurface, and atmospheric water will act under a variety of given circumstances are no longer reliable. And what this means is that we built and continue to build our society and our entire infrastructure that supports it around hydroclimatic norms that no longer exist and will not exist in the future. And climate change is now poised to compound that vulnerability and further multiply these risks. And the problem with it is that we're not ready for this. We do not as yet have an adequate replacement for stationarity statistics. In a rapidly changing climate, such statistics, in fact, become a moving target. And until we find a new way of substantiating appropriate action in the absence of stationarity, then risks will become increasingly difficult to predict or to price. And these are important considerations. Now, fortunately, it's not the end of the world. Liquid water, snow, and ice respond directly, visibly, and measurably to temperature. So if we follow what's happening to our water, it should tell us what's happening to our climate and how we might adapt to the conditions that we might expect in the future. So I propose to begin following climate's effect on water supply in Alberta by observing what the climate is doing to our ice and then to our snow. Now, up until now, North American attention has been focused on the rapid loss of glacier ice in Glacier National Park in the United States. Now, all of you have heard this, that in Glacier, 113 of the 150 glaciers that existed in 1860 have vanished. And the reason for that attention, I should point out, is what the Americans actually knew what was happening to their ice. And we didn't until now. And what is really interesting is through the efforts of IP3 and the Western Canadian Cryospheric Network, we now know that we may have lost as many as 300 glaciers in the Canadian Rockies between 1920 and 2005. And it appears that 150 of these glaciers may have disappeared in the 65 years between 1920 and 1985, and the remainder, the other 150, disappeared into thin air in the 20 years between 1985 and 2005, which gives you a sense that the loss is accelerating. And I want to point out the outstanding work done by Dr. Gary Clark at the University of British Columbia, who in my mind is one of this country's most prominent glaciologists. And I want to show you an area of Alberta that many of you know. This is the Columbia Icefield Parkway, the Icefields Parkway between Lake Louise and Jasper. And I want to point out the major ice fields that exist there. Bottom left going to the top, the Waputk, the Wapta, the Freshfield, the Mons, the Lyell, and the Columbia. And I point out the Columbia ice field because many of you have been there. So I want to point out what the projection is here in terms of what the mass of these particular ice fields will be over the course of the coming century. So we start now, and let's just go through what happens through the course of the century. Now, I want to point out that these projections are based on actual temperature changes measured over the last 40 years, projected to the end of the century. So I'm not projecting increased warming. What I'm saying is that if the trend over the last 40 years persists into the future, this is what we're going to see. So there's 2100. Here's now, this is what it'll look like at the end of the century. Now I want to give you one other, because I know that many of you have been to the Columbia Icefield. So this is the Athabasca Glacier. This is where you go and get on the snow coach. And I'll give you a sense of how we do this. We try to understand subsurface topography. We put the glacier mass back on it. We use a number of algorithms to determine what the rate of change will be under a variety of climate change scenarios. So this is what the kinds of changes will look like progressing through this century. So you can see that it's going to be hard to get a snow coach on that thing very soon. Now, what is very interesting is that when we look at this, we begin to understand that it's going to have a big effect on water supply. Glaciologist Dr. Sean Marshall has observed that current glacial contribution to Alberta mountain rivers is in the order of magnitude of about 1.2 cubic kilometers of water a year. And when you think of the total water supply, that is actually significant. He estimates that as this century progresses, that this volume will be reduced to as little as 0.66 cubic kilometers a year. And then if these temperature trends persist, they will drop to zero. So Marshall's preliminary first order estimates indicate that at current rates of melt, more than 90% of the roughly 45 cubic kilometers of glacier ice remaining in the Alberta Rockies will be gone by the end of this century. And if the temperature trends we have witnessed over the last 40 years, well, as Bill was saying, the Bow Glacier at the headwaters of the Bow River could disappear somewhere around 2160. The ice at the headwaters of the North Saskatchewan could melt away by 2170, and the glacial sources of the Athabasca River could disappear by 2180. And what you see is only the glaciers at the headwaters of the Peace and the Red Deer would actually survive into the next century. And because they are located in high north-facing cirques, the glaciers at the headwaters of the Peace might survive another 100 years, and those in the high mountains at the headwaters of the Red Deer might make it into the middle of the next century. And I want to point out that these are only first-order calculations that need to be verified by more accurate measurements of the exact volume of ice that exists in the Canadian Rockies. And that work's being undertaken as we speak by a team led by this man. This is Dr. Mike DeMuth, who's the head of the glaciology section of the Geological Survey of Canada. And at this very moment, DeMuth is conducting a ground-penetrating radar survey of the Columbia Icefield. And this research initiative in which we're involved is going to last for 5 years. And the objective of this research is to be able to determine two things. First, what does the subsurface topography of the Columbia Icefield region look like? And secondly, what is the exact volume of ice contained therein? And from this information, it will be possible to produce far more accurate estimates of exactly how much ice remains in the glaciers of the entire Mountain West and how much water we can expect these glaciers to produce over time in the broadest range of climate scenarios, which will be very useful to you in agriculture. Now, what is happening to our glaciers is, of course, of great importance to the future climate of the Canadian West. And some people have argued that, well, glaciers may not be as important in terms of total supply as they once were because they're already receding. But I think it's very, very important to see glacial recession in a much larger climatic context. We know that long before warming has finished reducing the length and depth of our glaciers, it'll already be after our mountain snowpacks. And that will have an enormous impact on water security. Almost Almost all of the 9.9 million square kilometer area of Canada can be covered by snow in January of any given year. And snow cover influences the global climate system in a number of very significant ways. The first influence has to do with the extraordinary extent to which snow and ice reflect the sunlight that falls on it back into the atmosphere. And this high degree of reflectivity, or albedo as it's called, operates in itself as a climate feedback mechanism. What happens is that the expansion of surface snow and ice cover increases the albedo, thereby increasing the reflected solar radiation, which lowers the temperature, thus enabling ice and snow to expand further. Now, over the past 2 decades in particular, however, this effect has been working in the opposite direction. Snow and ice cover is shrinking, lowering the albedo, and increasing the absorption of solar radiation, which in turn is increasing temperatures, which further reduces snow and ice cover. So we have the reverse feedback now. And another powerful influence the presence of snow exerts upon the hydrological cycle relates to the amount of heat involved in changing the state of water back and forth into solid and liquid form. And all of you know that snow is a really powerful refrigerant. It takes the same amount of energy to melt 1 kilogram of snow at 0 degrees Celsius as it does to raise the temperature of 1 kilogram of liquid water 79 degrees. So that threshold of freezing is a major thermodynamic barrier. And snow keeps a lot of heat out of the atmosphere. So mean monthly temperatures can be cooled by as much as 5 degrees Celsius just by the presence of snow. And the point that I want to make here that's relevant is the duration of annual snow cover in the southern Canadian Rockies has diminished by 1 to 2 months since observations began in the 1960s. So when the snow goes, things warm up. Fall, winter, and spring temperatures rise. Another way in which snow influences the global hydrological cycle is through the storage of water in glaciers and in the snowpack, and the associated delays that in freshwater runoff that occur as a result of that storage. And you know yourselves that we forget this sometimes, though, that snow is a reservoir that stores water in exactly the same way as a dam does for gradual release downstream over the course of the spring and in many mountain ranges well into the summer. And as I pointed out here, there's just not enough money in the world to build all the dams that would be required to store all the water that the winter snowpack does for later release into streams and rivers in the Canadian West and particularly in Alberta. And the point I want to make here is that cold provides this invaluable service for free. So, what will the Mountain West look like if we keep losing our snow? Now, Dan Fagre and his colleagues at the U.S. Geological Service have created a model that depicts glacial recession and landscape change as a consequence of current warming trends in Glacier National Park in Montana. So watch this, and you can see what's happening here. This is how the Glacier Park lost all of its glaciers in the last century and a half. But this also projects this forward, and I'll let it go through one more time for you to see this. And what you see here is that starting in 1850, you begin to see the glaciers recede, and you can see how the newly deglaciated landscape is gradually cultivated by different types of vegetative complexes. You see the alpine rising up, but over time, as temperatures rise, what you see is really interesting, because you see naturally bush and then you see forest, and what's interesting is you start to see grasslands rising up the mountain slopes. And it's what's happening outside of the frame here that is most interesting. When you look at this and when you see what's happening to the mountain range, think of what's occurring elsewhere surrounding those mountain ranges and what's causing that temperature and thermal situation to change at that altitude. What you're seeing outside the frame is the desertification of the northern prairies. So the key point I want to make here is that we don't have as much water as we think we do. And we may have generally less and sometimes catastrophically more than we have now in many places in a much more crowded and complicated world in the future. So what are the implications for agriculture? Well, I think agriculture faces a number of very serious water security challenges. In many parts of the country, especially in the West, there's going to be less water and more people who need it. And the agricultural sector in Canada should expect growing and, I should point out from international example, sometimes bitter competition from cities, industry, and the energy sector for water it now largely takes for granted. The second matter I'd like to discuss relates to the fact that growing and processing food requires a lot of water, and much of the return flows from agriculture are not of sufficient quality to be used for other purposes unless heavily treated. Now, I want to point out, we're not alone in this. This is a global problem. Agricultural water use is becoming an issue globally because contemporary industrial-scale food production practices inevitably result in reduced return flows to nature of water of poor quality, which diminished and often water-starved natural systems no longer have the capacity to purify. And this is a global issue, and we need to address it. And the third issue relates to the critical role of water in agricultural productivity. As I said when I began, agriculture matters. It matters to our economy, and it matters to our future. But unless we manage our water more efficiently and diminish water contamination threats to food security, we may not be able to take full advantage of Canada's opportunity to feed the world by exporting what we can grow with water and by exporting water embedded in food virtually to water-scarce countries elsewhere. So it occurs to me that with this opportunity to speak to you today, that agriculture really has no choice. You can't sit back and wait, hoping that your water security needs will be understood in some kind of grateful historical context. Agriculture has to engage vigorously and proactively in addressing what is quickly becoming a growing national and global debate on water security. And I think agriculture should engage in that debate in a manner commensurate with its importance to our economy and its relevance to human dignity and well-being globally now and in the future. Thank you very much.